Welcome back. In this video, we are going to discuss about the asymptotic notation. Asymptotic notation, it is the mathematical concept and it is used to describe the behavior of algorithm as their input size grows. And also it will analyzes the efficiency and performance of algorithm. Basically, this notations which is used to compare the time and space complexity, and also it will be a machine constants. Then it does not require algorithm to be implemented, and it will be focusing on the time and the space complexity. Okay. Then the different types of notations are big O notation, omega notation, and the theta notation. Then it will be the if growing with the same rate, it is called as the big O notations. Okay. Then slower, it will have omega notation, and the growing is the faster is theta notations. This categories algorithms, it will be based on the best case, and the average case. Okay. Then first we will discuss about the big O notation. The big O notation, it will describes the upper bound of a time complexity, and it will give the worst case. Then this big O notations maximum, it will be used to calculate the maximum amount of time which is taken for the execution. Okay. Then the big O notation which is represented in the for example for given function f of n, then it is generated function as g of n. It will use the set of function is called big O of g of n. This is the graphical representation. This function f of n, it is the constant function. Then this c into g of n, it is a function which is generated through the common boundary values. Then this is the example. Function f of n equal to 2n plus 3, g of n is n. Then you have to apply the formula f of n is less than or equal to c into g of n. We have to check. Then 2n into 3 n, then we have to apply in this formula and we have to find out the solution. Next one is the omega notation. The omega notation, it describes the lower bound on the time complexity of an algorithm. In this, the function f of n and the omega of c dot g of n, if there is any positive constants exist, it will give about the lower bound value. And this is the equation to how to calculate the value. Here the g of n will be represented in the below of that f of n. Okay, then meeting point also represented. And then this is the example 3n plus 2. We have to apply f of n equal to 3n plus 2, 3n plus 2 greater than or equal to 1 into n, the c equal to 1. Then we have to calculate n value is 1. So 3 into 1 is 3 plus 2 5, greater than or equal to 1, condition is true. Okay. It means that f of n is belongs to omega of g of n. Okay. The next one is the theta notation. The theta notation, it provides a type bound on a time complexity. C1 of g of n less than or equal to f of n, and C2 of g of n, because upper bound and lower bounds are there. This is the diagrammatic representation. F of n is there, and this c into g of n and c into g of n. One is upper bound and one is lower bound. Then example for this, f of n equal to 3n plus 2. Then we have to apply in the formula. Condition is false, n equal to 2, we get 2, the condition is get true. Next also, then it will be a condition is satisfied. It is the reference book. Thank you.